In this video, we're going to talk about imaginary and complex numbers. Now, you may not have a whole lot of background with these two terms, but I'm going to show you what they are, and the process is very similar to other algebra skills. By definition, an imaginary number is going to be the square root of a -1. So, for example, if we had the square root of 4 times the square root of -4, we get the square root of -16 when you multiply those together. Well, I know that if I took the square root of that, that's 4, and what I have left is square root of -1. So by definition, they call that 4i. Okay, so whenever you have that square root of -1, it's an imaginary number. Now, there are a couple other things that can help you as well. If you ever have I squared, that's equal to -1. If you have I to the third, that's equal to -I. And if you have I to the fourth, it's equal to 1. And so we're just going to play around with them a little bit just to make sure we understand. So just to use an example like we just did, let's say we have the square root of -36. Well, the square root, I know that 6 times 6 is 36, so the 6 comes out, and I have the square root of -1, so by definition, that's 6i due to that definition. Okay? Now, these imaginary numbers, using these things, can be used in what are called complex numbers. And in a complex number has the following general formula. And it is going to be a plus b with an imaginary number. That's what it always looks like. Now, let's just take an example. Let's say we have 4 plus 5i, and we're going to add 7 minus 7i. Well, it's going to work very similarly to when you had something like this, 4 plus 5x plus 7 minus 7x. It's almost the same thing. These two can go together, and these two can go together. Okay? And so it's going to do the same thing. So when you put them together, these two go together because they're just integers. And here they have that I component. So you have 11, and then it's plus 5 minus 7 is minus 2i. 11 minus 2i. You'll notice it's still in the same standard form or general form there. And that's how you do that. Notice it's always the number plus the number that's with I. It's never flipped around the other way. So minus 2i plus 11 is inaccurate. It's never written like that. Okay, it's always written in that general form. Now, if it would have been a subtraction, it's exactly the same thing. I know that the minus going to everything inside, that would become minus, and that would become plus. So I put my components together, I get minus 3, that's the 4 and the minus 7, and 7 and 5 plus 12i. That's how I would do one that had a subtraction. The subtraction moved through. But again, you'll notice I'm still in the same general form. If I go to multiply, it's going to be slightly different, but it's going to look exactly like something we've seen before. Let's take this and this. All you're going to do is multiply through. So 3 times 3 is 9. 3 times that is minus 6i. These two multiplied plus 15i. And then the last two is minus 10i squared. Now, first thing I see is these two are alike. So that's a 9i, minus 6 plus 15. So it's 9 plus 9i. And then I notice from up here, I squared is minus 1, so all of that's a minus 1. A minus 1 times a minus 10 is a plus 10, so that means I can put those two together, and I get 19 plus 9i. You'll notice it's still in that form that it's supposed to be in. So I multiplied through, and I used these little shortcuts to help me, and I put them together. So that's what one like that would look like. If you were doing division, it's going to look slightly different. So let's say we had 4 over 3 minus 2i. And they want you to simplify into the general formula. Well, the first thing you have to know is trying to get the imaginary number off the bottom is very similar to some other things you've seen in math. Okay, so what you have to do is multiply by the opposite, or what they call the conjugate. Well, let me help you real quick. 3 minus 2i, the conjugate is 3 plus 2i. Let me explain real quick. If I multiply through, that's 9 plus 6i minus 6i. Notice how those went away. And then the last term here is a minus 4i squared. Now I know that I squared is minus 1, so multiplying minus 4 times minus 1 is a plus 4, so 9 plus 4, 13. I got rid of all the imaginary numbers in there, and it broke down to that. So let me show you what it looks like in this one. If I wanted to simplify and get it into this form, I'm going to multiply the top and the bottom by 3 plus 2i. What I do on the top, I do on the bottom, because in reality, that over that is equal to 1. So when I multiply the bottom, you just saw me do this, but I'll do it again. It's 9 plus 6i minus 6i. So we know those are gone. And then that is minus 4i squared. The I squared is minus 1. So that is 9 plus 4, which is 13 on the bottom. The top is going to be 4 times 3 is 12 and plus 8i. And so all of that is over 13. But you'll notice the formula is a number plus a number I. So I can't have it in big fraction form, so I can do it like this. 12 13ths plus 8i over 13. And there, that's as far as I can reduce that thing down, just using what I know. Okay? Now sometimes the number may have come out where this wasn't a 13. Let's say that the number wasn't a 13. Let's say it's a 12. Okay, well then that would change everything here, because 12 goes into 12 one time, so that equals 1. And 8 goes into 12. Let's say I can reduce a 4 goes into that. That's 2i over 3. So sometimes things will reduce down, or they will break down. And so when you multiply by the opposite, it gets that imaginary out of the bottom of the term. Okay? So let's look at another one real quick. Imaginary numbers also sometimes show up when you have to use the quadratic equation. Okay? And so here's an example. X squared minus 3x plus 6 equals 0. If you tried to factor that, I tried doing that before the video, this one won't factor. Since it's a plus sign, that means that you have to have two things that multiply to get 6 but add together to give you 3. Well, 6 can be 3 and 2, but if you add those together, that's 5. That's way too much. 6, if that were a 6 and that were a 1, those would add up to 7. So it doesn't work. So you have to revert to the quadratic equation. So x equals minus b plus or minus the square root of b squared minus 4ac over 2a. And so I'm going to plug into that. So minus, okay, just a reminder, this is a, this is b, this is c. These are the large numbers. So a is 1, b is minus 3, and c is a 6. So minus b, so minus 3 is a 3, plus or minus the square root of b squared, 3 squared is 9, minus 4 times a, which is 1, times c is 6, over 2 times a, which is 2 times 1. I'm going to take the formula out to make it a lot less cluttered. Now you'll notice what happens here. 3 plus or minus, okay, so this is 9 minus 24. So 9 minus 24 is 15. So this is a minus 15 over 2. Well, the only thing I can do there, that's no square root at all. So I would have 3 plus or minus the square root. If I made this into 15 times minus 1, I could take out the I, leave the square roots of 15 there, over 2, and that would be my answer. Okay? And so I had that square root of negative 1, so I could take the I out. There's 15 is not an exact square. Let's pretend for a minute. Let's say that would have come out to a 16. Well, 4 times 4 is 16. So then I would have had, this would have been a 4i, because the 16 square root is 16, and then I could go from there. Then it would have been 3 plus 4i over 2, and 3 minus 4i over 2. And so different things happen, but that imaginary number came out because I had a square root of a negative number. In the next video, you're going to get to play with this and try to rearrange and play with these complex and imaginary numbers.